Okay. So till yesterday we have completed our VPN concepts like site-to-site VPN and remote access VPN. Both we have checked yesterday. Today we will move with another concept. We call it a high availability, or some people call it a HA in short. So high availability is like redundancy when you want to have more than one firewall. Where your one firewall goes down, your network should not go down. For example, assume this is my environment. Just give me 1 minute, guys. Okay. Assume this is my environment. This is my firewall. I am having multiple ISPs connected. ISP1, ISP2. Okay. Both of these are connected to this firewall only. Then I may be having more than one core switch, doesn't matter. This is my one core switch. Then I can be having another core switch. Both are connected in a stack. Then I may be having a couple of L2 switches. Everything I am having a redundancy. Then I am having a users connected. Okay. But at a firewall level, I am having single firewall, right? If this firewall goes down, what will happen? My entire network goes down, correct?
Yes.
Is it clear?
Yeah.
So what will happen if 1 minute, guys? Just give me 1 minute. Stop the stream. Okay. So what I was saying, if this firewall goes down, my entire network went down, right? So we don't want this type of scenario in our environment, that there is a dependency on single device or single hardware. If this hardware goes down, I should be having a redundancy setup, like the switches should be connected to another firewall. Okay, and this core switch to also connected to another firewall. And in any of the case, if this firewall goes down, my traffic should be going from another firewall, and my users, or my internal users or my external users, whoever is accessing my services, they should not get any interruptions. My services or my operations or business should be running at any given time, right? This is our main requirement when we are having a high availability. Nothing, in simple terms, if you want to know high availability, it means you should have more than one device acting as a redundancy. And it is like, suppose for example, two people working in one office. If one person, suppose this is a person 1, this is a person 2, majorly everything or all the load would be taken by major person 1, and if he is down, a person 2 would be taking his load also at any given time. Or if suppose there is an emergency and this person is absent in your office, all the work should be done by person 2, and there should be no business disruptions, or the traffic or the business should be running at any given time. Similar to that, in our firewalls also, we have like more than one firewall we will purchase. So if one firewall went down, then another firewall will take the role and send the traffic or pass the traffic from our LAN to WAN, or from outside to inside. Okay, is it clear?
Yes. Clear.
Yes.
Okay.
Clear.
So this is a simple terminology. High availability provides redundancy in the network to ensure services continuous in case a device failure or link failure on the firewall. In FortiGate, HA is implemented using a FortiGate clustering protocol. So whenever we try to install a FortiGate HA, there is a protocol, inbuilt protocol, we call it a FGCP, FortiGate clustering protocol, which allows multiple firewalls to operate as a single cluster. Cluster is nothing but a HA, or a high availability. Okay, FortiGate HA can be configured in two ways. Now we understood what is a HA. Whenever we want to configure a HA, there are two modes available in HA. Okay, so now let us see HA modes. One mode we call it active / passive, and that is the common mode everyone uses. Then second mode is active. So what happens in active passive? Both the firewalls, one firewall would be sending all traffic, and other firewall will be in a standby. Assume you have a topology, same topology what we have previously. This is my firewall 1. Then I am having another firewall. Okay, then I am having some type of WAN switch, then I am having a ISP. Okay, ISP is connected to WAN switch, then WAN switches is connected to our firewalls. Between a firewall there would be a link, we call it a HA link or a sync link. HA sync we call it. Then we would be having a device called a LAN switches. It can be more than one LAN switch, doesn't matter. Okay, and then the firewall would be connected to our LAN switches also. Then underneath we would be having a users. When we have an active passive scenario, one firewall would be acting as active or a master, another firewall would be acting as a passive or a standby. Okay, so whoever is a active or a master firewall, traffic would be going. Suppose a user is connected to L3 switch, traffic would be flowing in this scenario in our environment. Okay, if this firewall is active. If this firewall is in a standby mode, assume this is in a standby mode, then traffic will not flow from here, traffic would be flowing from this scenario. Okay, so if this is active, traffic will flow from firewall 2, and the second firewall, whoever is a passive firewall, he will be only in a standby mode, he will not send any traffic in our environment. Okay, is it clear?
Yeah.
Okay, then we are having another firewall, we call it active. In an active firewall, what happens? Both the firewalls would be sending a traffic or load balancing the traffic. Traffic would be load balanced between firewall 1 and firewall 2 when the traffic is going out of our firewall. Okay, but there is a scenario. Not all the traffic would be load balanced, only UTM traffic, which means if you have like a web filter, app control, or you say IPS control, or anything antivirus control, whatever the security profiles are there, right? That is only load balanced when we have a active scenario. Rest all normal TCP sessions. Normal TCP sessions I am saying, which doesn't have a UTP traffic or UTM bundle, the traffic will not be load balanced. The traffic will only handled by our active firewall. Okay, is it clear?
Yeah. Okay. Yeah, I got it.
Okay, then let us go to next scenario. Okay, let us go to theory. Okay, one more time. So what happens in active passive mode? In this mode, one firewall operates as an active device and handles all the network traffic, while the second firewall remains in a standby mode. If that active firewall fails, the standby device automatically takes over and becomes the active firewall. In active mode, in this mode, firewall both firewall operates as an active member of the cluster, and traffic is load balanced between them, improving performance and resource utilization. But the twist is only UTM traffic would be load balanced, not all the traffic. Okay, now we understood what is active and active passive. Let us go to next topic. How does a active selection happens, or we call it a election? Which device will become active or which device will become a passive? How does we firewall knows now? For this, there would be election between the firewall. Let us see. Now assume I am having two firewalls, right? By default, there would be no active or no passive, right? We will just configure a firewall in HA. Now, how firewalls will be knowing which, either firewall 1 or firewall 2, which device should become active firewall? There would be some criteria need to be there for active firewall or passive firewall. Before we go to that criteria, let us go to another thing. We call it a link monitor. Okay, so assume now I am having a WAN link and a LAN link. So for example, there are two types of failover we can have in a firewall. One is a hardware failover, or second is a link fail. Okay, link fail firewall will only try to monitor when we configure link monitoring in our firewall. Say hardware failover means if this complete box went down, suppose this firewall is acting as active, if this goes down, second firewall will become active. Okay, the role failover we call it with the hardware. if suppose this firewall is not active, suppose this firewall is in a up and running state, only this WAN link went down, still the traffic will be going from this firewall and he cannot send the traffic out, right? Because this WAN link went down, still our network or our internal LAN will have a no internet connection, correct? Because the source is sending traffic to switch, switch is sending to firewall 1, and firewall 1 WAN link is down now. So for this issue, what we will do, we will configure link monitoring. We will tell to firewall, we will tell firewall 1, firewall 2, okay, link we say WAN link monitor. This also will say WAN link monitor. Not only WAN, we can say LAN link also monitor. Here also will say LAN link monitor. Okay. In this case, what will happen? Scenario: if any link monitoring, if any monitor link fails, change the role. Change the role means if you are active. If active, become passive or become standby. Okay. Same thing. If any link monitoring fails in firewall 2 also, if he is active, he will be in a standby, and second firewall would be a active firewall. Okay. Is it clear? Link monitoring. Sorry. Okay. Yeah. Then let us go to the criteria now. What is the criteria for which device should become active? There should be some criteria. So now let us see. Let us go to next. Okay. The primary unit selection in a FortiGate HA cluster follows a specific order of checks. The FortiGate clustering protocol evaluates this condition sequentially, and the selection process stops as soon as the first matching criteria. Okay. So the first matching criteria is monitor interface status. Okay. Monitor interface status. Suppose in a firewall 1, I have two monitoring interfaces. In a firewall 2 also, I have two monitoring interfaces. Okay. In firewall, either of the firewall, suppose firewall 1 WAN interface is down, and in firewall 2 both interfaces are up, then the criteria is least monitor interface. Firewall should become active. Okay. So in this case, which firewall is having least monitoring interface down? 1 minute. Face down should become a active firewall. So in our case, both the firewalls we have two monitoring interfaces, right? Number 2, number 2. But here only one is up and one is other one is down. But here both the things are up only. So in this case, what will happen? Firewall 2 become active and firewall 1 will become a standby firewall, if this condition is meeting. If this condition says, 1 minute, if condition 1 says both firewall monitor interfaces are up, okay, then go to second condition. Okay. If in case and maximum both the interfaces would be up and running in our monitoring interfaces, then it will go to a second condition. What is the second condition? Let us see. The first condition is clear, right? Okay, we'll go to second condition. Second condition, HA uptime. So HA uptime means it is not the device uptime, it is the cluster uptime. Okay. Suppose firewall 1 configured on 7:30, firewall 2 configured on 7:40. Okay. So what does the condition says? The device with the longer HA uptime, right? So Now what is the time? 7:50, right? So which firewall was configured first? Firewall 1 was configured first, right? So FW1 will become active. If in case the time difference is less than 5 minutes, then it will go to third condition. If the time difference is less than 10, more than 5 minutes or 10 minutes, 15 minutes and all, then whichever firewall was configured first, that will become active, and the second firewall will become a standby firewall. Okay? If it is equal or less than 5 minutes, then go to third condition. Okay? Is it clear? Third condition, let us see. Device priority. Each firewall can be assigned a priority value, the device with the higher priority, right? The default priority is 128. If you don't change, the firewall will have a default priority. Now if you want like a firewall 1 to become active, you can make the priority from 120 to 150 or 255. The maximum priority is 255. Okay? And firewall 2, you can keep it to 128. Then firewall 1 is having the higher priority, that will become your active firewall. Okay? If you don't change this, then default priority is 128. It will go to fourth condition. So fourth condition is a tiebreaker. It would be the final condition. So what is the fourth condition? Highest serial number. Both of the firewalls would be having their own serial number, right? Whichever firewall is having the highest serial number, that will become the active firewall, and another firewall will become a standby firewall. Okay? Is it clear? Hello? Hello guys? Am I audible?
Yes, clear.
Yes.
Okay. So now let us recap one more time shortly. So negotiation begin in each of the firewall. First, they will check a failed interfaces. If which firewall is having the less number of failed interfaces, that will become a primary. Okay? And which firewall is having the greater number of failed interfaces, that will become a secondary. If both are equal, then it will go to the highest uptime of a cluster. The older the firewall, or the one which is configured before, suppose this is configured 730, this is configured 740, this is older one, right? That will become a primary, and the later configured one will become a secondary firewall. Okay? If both are equal, age is also equal, like less than 5 minutes. Suppose this is configured 730 and this is configured 733. So a firewall will check difference of a time more than 5 minutes. If it is less than 5 minutes, then it assume it is a equal, then it will go to third condition. Third condition is a device priority. Whichever firewall is having higher priority, that will become a primary firewall. If again third condition is also equal, it will go to the serial number. The serial number will not be same in both the firewalls. Remember, serial number in both the firewalls would be different all the time. Okay? So whichever firewall is having the highest serial number, that will become a primary firewall. Okay? Is it clear? And this particular election is same, either you go for active or you go for active passive scenario. Which firewall should become a master and which firewall should become a standby or slave would be decided based on this particular conditions only. Okay? Okay. So now let us see how does the traffic flow happens in our high availability scenario. Okay? Just a minute. Traffic flow. Let me copy this. traffic flow would be slightly different in active active and active passive scenario. Now let us see. First we will go with the active passive, which is very common. Everyone will use active passive in many of the environments. So suppose this firewall is active now and he wins the election for a master firewall, okay, or active, or you can call it a master, and this firewall is a standby mode as of now. So whichever firewall is a active firewall, that will get one virtual MAC. You remember when you were learning about HSRP, VRRP and all, there would be one virtual MAC and virtual IP address to a gateway of our HSRP, right? Similar to that, the active firewall would be having one virtual MAC given by FortiGate clustering protocol. Okay. So whenever a user, suppose this IP is IP on both the firewalls. Assume now I am having active passive scenario. Interface firewall 1, firewall 2, then MAC. Okay, then okay, interface, LAN interface. In firewall 1 also the IP would be same, firewall 2 also IP would be same. MAC, firewall 1 will have virtual MAC. Okay, firewall 2 will not have any virtual MAC. Then WAN also same thing. Suppose 100.1.1.1, firewall 2 also having same IP. The configurations would be identical in both the firewalls. Only thing is, in a firewall 1, whichever firewall is active firewall, okay, MAC table or MAC interface MAC. In firewall 1, firewall 2. Firewall 1 would be having two MAC addresses per interfaces. Firewall 1, whichever, suppose firewall 1 is an active firewall. This is a standby firewall. Okay, firewall 2 is a standby firewall. It would be having only one MAC. That is called a physical MAC. But in firewall 1, we would be having one physical MAC. That is came with the interface. Then we would be having another MAC. We call it one VMAC. That would be given by our clustering protocol, FGCP protocol. Okay. Now what will happen? Suppose a user, whenever user is trying to do ARP entry or ARP request, okay, so request will go to both the firewalls, but only a active firewall will reply with the virtual MAC address. Okay, so suppose a user is having 192.168.1.100 and his gateway is 192.168.1.1. okay. Now user wants to go to internet. What he will do? First he will try to resolve a gateway ARP, right? So he will send a ARP request for this particular IP address. The traffic will go to a firewall, and firewall, instead of replying with the physical MAC, he will reply with the virtual MAC. And user will be knowing, okay, this particular IP address is having the ARP entry of this particular MAC address, okay, which is our virtual MAC address. Like that, the traffic will flow. The traffic will flow based on the virtual MAC instead of a physical MAC in our FortiGate clustering protocol. Okay. And in any given case, if the active firewall goes down, this virtual MAC would be shifted from primary firewall to secondary firewall, which will become active later. Okay. Suppose this firewall become a standby and this firewall become active, the virtual MAC would be shifted from primary firewall to secondary firewall. Okay. Is it clear? Any questions, guys? Okay, then let us go to another scenario, very similar to active passive, but in active there would be slight difference how the load balancing will happen. In active passive also, actual ARP from a client to firewall, or from a firewall or from a server to firewall, actual ARP resolution would be happening on a VMAC only. Okay, but a load balancing time, a firewall 1, suppose the request came from a user to a firewall 1, which is active firewall or master firewall. If this firewall need to be, this traffic need to be load balanced, firewall 1 will send this traffic to firewall 2, then firewall 2 will send out, then return traffic will again come to firewall 1, he will send to firewall 2, and firewall 2 will send to a user. Okay, like this, in our active scenario there would be multiple MAC addresses. Assume client initiate traffic to active firewall, then if active firewall decide this traffic need to be handled by second firewall, then primary firewall sends traffic to secondary firewall. Okay, then secondary firewall will do all the inspections and send out. Okay, then reverse traffic, then server to traffic will come to active firewall again, but this traffic was handled by our secondary firewall, so active firewall again send the traffic to to secondary firewall, then secondary firewall will send the traffic to client. Like this, there would be multiple to and fro communication when we are having active passive scenario. But when we are having active scenario, but when we are having active passive, what will happen? Client sent to, then firewall will send to server, then server sent to firewall, firewall sent to client. This was the simple communication when we are having active passive, right? There would be no traffic sent from active to secondary or secondary to active again. But in active what was happening? There are two more steps. Client sent to active firewall, this is there in active passive also, no problem. Then the server sent to active, this is also there in active passive. But this particular scenarios, primary firewall sent to secondary firewall sent to server, active firewall sent to primary, secondary firewall sent to client. These are the more steps available when we are having active passive, right? You can say two more steps available in our active passive scenario when we are doing a load balancing. Okay, is it clear? Hello?
Yes, clear.
Okay, then how does a virtual MAC is decided when we are having a active or active passive? The virtual MAC would be decided. Okay, so the virtual MAC usually comes with like you can say VMAC prefix. So whenever you configure HA, you need to give some group number. So based on your group number, the VMAC would be decided. So if your group number is 0 to 255, this would be your VMAC. Then your VDOM ID, suppose you are working on VDOM 00, then your VDOM ID would be 0. Then interface index, whatever your interface index is there, that would be taken place. Okay, suppose your interface index is 0, number 2, then this would be your VMAC prefix, then your VDOM ID, then your interface prefix. That would be the usual scenario whenever you are configuring a HA. This you don't need to configure automatically. The protocol will do this, but you need to know. Okay, if you are having this particular group, then this would be your VDOM prefix. If you are having group number from this, then this would be your VDOM prefix. Okay, is it clear? Okay, then what is the bare minimum requirement to configure a HA? Let us see. Whenever you try to configure HA, the bare minimum requirement is hardware model should be same, software version should be same. Okay, group ID should be same, whatever the group ID you are configuring. Then password. This is the bare minimum required whenever we are configuring HA on any of the firewalls. Suppose I am having a one firewall 100E, another firewall 100F, then the HA will not be configured, the HA will not work properly. So the firewall should be same. Then version of both the firewalls should be same. whatever the group ID you are configuring, that should be same, and password on both the firewalls for HA should be same. Okay, is it clear? Okay, now we'll go to our lab. Just give me 1 minute, guys, I'll come. Okay, then we will try to configure a HA. Let us decide what are the subnets we will use. So WAN site, I will use 100.1.1.1 at a firewall level, and at a ISP router I will use 100.1.1.2. Okay, WAN means port number 4. Okay, done. This we will use here. Then we need to use at a firewall port 1, which is a LAN port. We will use 192.168.1.1/24. Okay, initially, for a time being, at both the firewalls, this firewall we will use 1.1 and another firewall we will use 1.2, because we need to configure a HA right first. So that for that we need a firewall access. Management PC 1.100 we will use. Done. Let me configure, start all the firewalls. ISP. 1 minute, I need the gateway management cloud. Done. Done. 1.100. Let us open this. So 192.168.1.100, 192.168.1.1. Done. First, let us configure the basic things like firewall management interfaces on both the sides. Later, we will enable a HA. We need a firewall access from GUI, right? Config system interface, edit port 1, set mode static, 192.168.1.1/24. Set IP 192.168.1.1/24. Set allow access, telnet. Done. Other side also I will configure management IP and keep it. Config system interface, edit port 1, set mode static, set IP 192.168.1.2. This would be for time being only. Later it would be changed automatically. When we enable HA, both the firewalls will have the same IP address only. Okay, that's it. Now let us do firewall config. One 192.168.1.1 and 192.168.1.2. Done. Let us configure. Initially we will not do any interface configuration, anything. We will just enable a HA and keep it. So if you wanted to check what is the current HA status on any of the firewall, you can go to firewall, get system HA status. As of now HA is what is HA status? HA mode status, okay. Current mode is standalone mode. That means HA is not configured as of now. It is in a standalone mode. Okay. Let us keep it. And the secondary firewall also. Let us see. Get the system HA status. Secondary also in a standalone mode only. Okay. Now let us enable HA. To enable HA, go to system, high availability, HA. Then you need to change the mode from standalone to active active or active passive. We will go with the active passive scenario. What is the device priority we need to give, then what is the group number. Suppose I give a group number as a HA, then I need to change a password. Password I can say FortiGate, or okay, we will give a password as a FortiGate. Then monitoring interfaces, if I wanted to configure, I can configure. I will say I wanted to configure monitoring interface port 1 and port 4. Okay, then what is a HA, heartbeat interface? In our case port 3 is a heartbeat interface. Okay, done. Then same thing I needed to configure in second firewall also. Never begin, I'll say FW2. Before that, let us see what is the HA status in FW1 now. Now HA status has been changed. You see mode, it become AP. A means active, P means passive. Okay, active passive. Then what is the messages we are seeing? Primary selected using. This is selected as a primary because it is the only member in the cluster. As of now we have only one member in the cluster, and that is selected as a primary firewall. Okay. Now let me enable a secondary also. System, high availability, I'll say active passive, then group number HA, group name HA, then change FortiGate. Monitoring interface, I will say I wanted to select port number 1 and port number 4. Then what is my HA interface? Port number 3. Done. Okay, HA has been configured. Now let us wait. Give me 1 minute. We'll say FW1. Done. Now let us see which firewall is active and which firewall is in a standby mode. Current firewall or our firewall. Secondary firewall is this, primary firewall is this. So let me get the serial number of both the firewalls first. Get system status. This firewall serial number is this one. Notepad. This is our FW1 serial number. Now let me get a FW2 serial number also, so that would be easy for us to understand. Okay. Now which firewall is active and which firewall is standby? Let us see. Get system HA status. Primary firewall is this one, and secondary firewall is another one. Let us see why it is primary. Is selected as a primary. Its serial number is larger than the peer serial number. Okay. What is the peer serial number and what is his serial number? So this firewall is selected as a primary. Our secondary firewall is selected as a active firewall. Okay. Why it is selected as active or primary? Because its serial number compared to another firewall is larger. So why it is larger? F, G, V, M, V. Instead of E, here he is having a F. F is treated as a larger number compared to E, right? So that's why it is selected as a larger number, and the secondary firewall become an active firewall. And you will be clearly able to see in our CLI also that okay, this firewall is selected as a primary firewall because its serial number is larger than the peer firewall. Okay, is it clear? Now we will be only able to take access of one firewall only now, because the IP address is in both the firewalls has been changed. 1.1, oh, sorry, it would be 1.2. okay, this would be the firewall IP address taken in both the firewalls. Now let me show you. So system interface port 2, okay, sorry, port 1, it is having 1.2 IP, and firewall 1 also changed from 1.1 to 1.2 now. So system interface port 1, it is out of sync as of now. Configuration has not been synced. Once synced, it will change from 1.1 to 1.2. okay, by the time we will do all the configurations in one firewall or our second firewall, we need to change the IP address from 1.2 to 1.1. I want the IP address to be 1.1 only. okay, I will change it to 1.1, and I will say this would be my LAN port, this would be my LAN zone. Done. Okay, I wanted to change it. Done. 192.168.1.1. okay, then I will change my configuration on a port number 4, which is my WAN port. Port number 4, my WAN port. IP address 100.1.1.1/24. ping. Done. Now let us see if HA has been synced, or it will take more time. It is not yet synced. We need to wait for some time. Once HA is synced, whatever configuration we did in primary, that would be replicated to secondary also. By that time, let me do static route configuration. I will say I just need one default route pointing towards 100.1.1.2 WAN side. Done. Then I would need one security policy also from LAN to WAN. LAN to WAN security policy. Incoming interface would be LAN, outgoing interface would be WAN. I'll say source as any for now, and destination also any for now. Then service also all. Done. All session output done. Let us configure a router quickly so the traffic can flow in our environment. Okay. Enable config t interface Ethernet 0/1 IP address. I will say this should be my DSCP. No shutdown. Then exit interface Ethernet 0/0 IP address 100.1.1.2. No shutdown. Done. Exit. Then one access list, IP access list standard 1 permit 100.1.1.0.0.0. okay, log. Exit interface Ethernet 0/0 IP NAT inside interface Ethernet 0/1 IP NAT outside. Sorry, we just configured the NATing configuration in both our ISP router interfaces. Then one NAT statement, IP NAT inside source list 1 interface Ethernet 0/1 overload. Done. Write memory. Now let us see from a client, are we able to get into internet. Before that, let us see system high availability is still not in a sync state. No problem. Let us see which firewall is having the MAC addresses. Usually our a primary firewall, which is our second firewall, active firewall, should get a MAC addresses, right? Or virtual MAC. How to check a virtual MAC? I have given in our command. There would be command diagnose hardware device info. Okay. Now suppose we are having two firewalls, right? We are having firewall 1, we are having firewall 2. Firewall 2 is acting as a primary and this is acting as a standby or secondary firewall. So remember, as per theory, a primary firewall will have one physical interface, physical MAC, and one virtual MAC per interface. Okay, so this interface should have 2 MAC, this interface should have 2 MAC. But a secondary firewall will have only one MAC, which is our physical MAC. One interface would be different physical MAC, another interface would be different physical MAC. Let us see if it is true or false. Diagnose device info. 1 minute. Diagnose hardware device info. NIC port 1. I'll say port 1. So let us see. There is one hardware address and one is permanent address. Hardware address would be your virtual MAC. Okay, then permanent address would be your physical MAC. Now let us copy this and we'll paste it in a notepad for a primary firewall. Remember, ARP resolutions will happen from this. Okay, ARP reply, or you can say a firewall will reply with this particular MAC. We will check a ARP table in our client, we will get to know. Then I will do same thing for a port number 4 also. So port number 4 is
possible.
Sorry. Hello. Yeah, Raghavan, you asked something? Yeah.
Hello.
Yeah. Am I audible, guys?
Yeah, clear.
Yeah.
Yes.
Raghavan,
Yes.
you asked something?
Yes.
See, this would be not physical MAC, this would be virtual MAC from where the client will get a ARP replies. Okay. Whenever a client do a ARP request, right, firewall will send a ARP reply from a virtual MAC only. Okay. So this would be for a WAN side and another one would be for a LAN side. Okay, done. Now let us try to initiate the traffic and we'll see. Okay, before that let us see on a firewall 1 also how many MAC we are having. Okay, diagnose hardware device info NIC port 1. If you see on this, a hardware MAC and a permanent MAC is exactly same, right? But in another firewall, a hardware MAC and a permanent MAC is different, right? Whichever firewall is permanent firewall or primary firewall, that would be having a hardware MAC different and permanent MAC different. Hardware MAC usually it would be a virtual MAC and permanent MAC would be our physical MAC. Okay. But in secondary firewall, a hardware MAC and a permanent MAC would be exactly same. There would be no other MAC address. Per port, there would be one MAC address available. Okay. Now let us see ARP-A. Now if you see for 1.1, what is the ARP resolution happening? ARP resolution happening with the virtual MAC 0009 0F09. If you see as per our theory, ARP resolution will happen with this 0009 0F09, and as per our theory also 0009 0F09 would be the Fortinet VMAC identifier, right, or vendor identifier. Then 00 would be our VDOM, then 00 would be our interface indicator, right, interface index ID. So we are getting a ARP reply from a firewall with a virtual MAC address instead of a physical MAC address. Okay, is it clear? Now suppose I start pinging 8.8.8.8 space -t. Are we getting replies? Yeah, we are getting reply. Now let us see if HA has been synced or not first. If HA synced, then okay, HA has been synced now. Now when the traffic is flowing in our environment, what is happening? From a user, traffic is coming and going via, from a user, traffic is coming and going via firewall 1, which is our primary firewall. From here it will go to router and it will go out. Same time when the router is replying, he will send the traffic to switch, switch will send to primary firewall will send to switch will send to a user. Okay. In any of the case, if this link went down, this firewall will become a primary, or this firewall went down, this firewall will become a primary. So now let us try to do one by one. What we will do on a primary firewall, let us make this particular link as a suspend stage. Then let us see what happens. Get the system HA status. Okay. So other firewall become a primary. Let us see if internet is working or not working. There was couple of request timeout. Again internet started working, right? So let us see if HA has been shifted or failover has been happened or not. Okay. Now which firewall is primary? A firewall 1 is primary. Previously a firewall 2 was primary, right? Now because of the link failover, a firewall 2 become a primary. Okay. Now let us see. Even we can see what is the reason for a failover. This firewall selected as a primary because link failover or there is a ping server failover is less than the peer member. So there was a link failover on the primary firewall, so another firewall become a primary or failover happen in our HA scenario. Okay. Let me bring the link again up and running. Resume. Let us wait for some time. Now firewall 1 is primary. HA is or traffic is flowing. Let us see. Firewall 1 only would be primary now. Now not only a link failover, if the device has been failed, still the failover will happen, and now you can see what will happen. Let us wait. Again traffic started flowing. Now a firewall 2 become a primary, and that is the only member available because another firewall went down in our environment. Okay. So like this, when you have a link failover, suppose you have a LAN link. Let me bring this firewall up and running again. Now what we did in our environment, we did a LAN link monitor, a WAN link monitor. Apart from this, the hardware monitor would be by default available. Suppose in a primary firewall, if this link went down, secondary firewall will become a primary. If this link went down, this will become a primary. Either of the link goes down, our second firewall will become a primary. Not only a link, if a complete device also went down, this device instead of secondary, it will become a primary. It will take over the load and it will start flowing the traffic in our environment. So users will not get the internet issues. Okay. Is it clear? Hello. Okay. So
Yes, clear.
let me know guys any questions. Let us recap what we did. First we understood what is HA. Then we understood modes of HA like active and active passive, right? Then how does a selection happen? Selection for active or a primary. How does the active and primary selection happen? Then what we did, VMAC criteria, VMAC interface or virtual MAC of a interface. How does it comes? It would be Fortinet vendor identifier, then VDOM, then interface index, right? This would be taken place. Okay, is it clear? Apart from this, we have checked like what is a link monitor, then what is the minimum criteria to make a HA up and running, how does the HA sync happens and all we have checked, right? So let me know guys if any questions in this or we'll wind up. Sorry Raghavan.
No, all good.
Okay. Then we'll wind up for today. We'll connect again tomorrow. Thank you all. Thank you.